All right, the next part of our lesson is also on slope, but it is more specific. It's on slope-intercept form, which is a way to write an equation that tells us a lot about the graph that it shows. When we take a look at slope-intercept form, we're going to take a look at an equation and dissect that equation to find both the slope and the intercept. And from there, we can go ahead and graph. To review, slope is the ratio of vertical change to horizontal change. It can be given by the formula, and we use this one, the y2 minus y1 over x2 minus x1 to calculate slope. Slope, it could be positive, negative, undefined, or zero. And we can use slope to help analyze real-world problems like rate of change. If you recall, we learned a standard form of an equation. We can go ahead and put a standard form into a function form. If you remember, we did that when we were talking about literal equations. If we were to rewrite this, let's see, we have ax plus by equals c. If we want function form, that means we want the y all by itself. So we would subtract ax on both sides. And I'm going to put my x first. Remember, the constant comes at the end. And then I would divide everywhere by b. And we'll get y equals a negative a over b x plus c over b. That's putting it into function form. And what you get is something like looks like this. Function form is also called slope-intercept form. The m, if you remember from our last lesson, the m represents a slope, the rise over run, and the b represents the y-intercept. So that's the dot that's along the y-axis. Find the slope and y-intercept of an equation by putting it into slope-intercept form and identifying m and b. So our first one is already in slope-intercept form. And if you're not sure, go ahead and write right above it. It should say y equals mx plus b. M is your slope. So what is the slope in this case? It's 3, or maybe 3 over 1. Remember, slope is rise over 1. You could do this, or you could just say 3. What is the y-intercept? That's right here, the constant hanging off the end of your equation. Your y-intercept is at positive 4. For letter B, it's not in slope-intercept form, right? I'll go ahead and write it down. Does it look the same way? No, it doesn't. I have 3 x's over here. They shouldn't be there. They should be on the other side. So we're going to go ahead and minus 3 x's on both sides. And if you recall, when we were learning this in solving literal equations, we always put the x term first. That minus 3x goes first, and the positive 2 will come second. Now it is in slope-intercept form. And from here, we can see that our slope is negative 3 over 1, or just negative 3. And our y-intercept, whoops, I'm thinking y-intercept, but the variable that represents that is b, is a positive 2. Go ahead and try the last one. It's got a couple extra steps here, so we're going to go ahead and I'm going to write what my equation should look like at the top. So I'm reminded of the form and order. I'm going to go ahead and subtract 3x just like we did on the other side. Get a negative 3y equals a negative 3x plus 12. And my last step is to divide everywhere by negative 3. I'll get my y equals negative 3 divided by negative 3 is a positive 1x. 12 divided by negative 3 is going to be a negative 4. So my slope is a positive 1, or 1 over 1 if you want. And my y-intercept is at minus 4. See that minus sign there? Minus 4, negative 4. If we're graphing using the slope-intercept form or y-intercept form, all we have to do is look at our equation and graph the y-intercept first and then the slope. This is quicker than doing the table of values method or even the intercept method. That's what we learned first. So first we put our linear equation in y=4 form. Then we identify the slope as a fraction. So we know the rise and we know the run. Remember, the rise is how far up and down you go, and the run is how left or right you go. And that y-intercept is hanging off the end there. We plot the y-intercept, and then we use our slope to go up and over to get to the next point on our line. If our slope is positive, we're going to go up and to the right. If it's negative, we can go down and to the right. We'll connect all of the points we have and make a line. Graph -2x plus y = 3. Again, I need it in y equals mx plus b form. So I'm going to get it there first. I'm going to add 2x on both sides. And we'll get y equals 2x plus 3. Then I want to go ahead and identify my slope as a fraction and the y-intercept. The slope in this case is 2 over 1, and the y-intercept is 3. Remember, your 2 over 1, your slope, means you're going to rise 2 and then run 1. So let's take a look. First, we plot our y-intercept. So I want to find 3 on the y-intercept, and that is up here. 1, 2, 3, right here. Put a big old dot there. That's your y-intercept. Never does it go along the x-axis. We only graph on the y-intercept for the y. From this dot, we're going to rise 2, so that means go up 2 and run 1. But do we go to the right or the left? Well, the 1 is positive, so we would always go to the right. So I have 2 points. I can connect them and make a line. But I also, for me, I need more dots so my line looks sort of straight. So even though I just rose up 2 and went to the right 1, if I go down 2 and to the left 1, I'm still putting more points that are going to fit along that line. So I'm going to add some more here. And then I'm just going to verify. My slope should be 2 over 1. So am I rising up 2 and going over 1? Up 2 and heading over 1? Up 2 and over 1 for every single dot? I am. And is my y-intercept at 3? Yes, it is, that big one right there. So now I can connect all the points I have and draw my line through them. Let's take the next one. Y equals 3x plus 2. 2 is my y-intercept, so I'm going to put a big old dot there. And then my slope is 3, or 3 over 1. So the top is positive, so that's a rise of 3, go up 3. And then the bottom is positive, so I go to the right 1. And just like before, I need more points, so I'm going to go in the reverse. And then just double check, did I rise up 3 and over 1? I did. So then here I can draw my line. Wow, that's pretty crooked, but you get the idea. All right, let's go ahead and put this in slope-intercept form, which means subtract x everywhere. We'll get y equals a negative x minus 3. Now, I like to put a 1 in front of my variables that don't have numbers there, so I can see exactly what the slope is. The slope is negative 1 over 1. My y-intercept is at negative 3, so I'm going to go ahead and graph my y-intercept first, and then use my slope of negative 1 over 1. So the top number is negative. That means I drop 1. But I still get to go to the right 1. Drop 1 and go to the right. And you know I need more points, so I'm going to go in the opposite direction or in reverse. And just make sure each and every time I've dropped down 1 and to the right 1. And then I can draw my line through. One other way to check is to go back to your equation in slope-intercept form. We said our slope was negative. Well, if we remember from our lesson on slope, that means our graph should be falling. as we read it from left to right, and that is what we have here in our graph. All right, let's take a look at this one. We're going to subtract 2x on both sides. Get 3y equals negative 2x minus 6. And then we have to divide by 3 everywhere, and I don't have the room. I'm going to put it up here. I get y equals negative 2 over 3x, and negative 6 divided by 3 is negative 2. So my slope is negative 2/3, and my y-intercept is negative 2. So I'm going to first plot my y-intercept. And now I use the slope to rise negative 2. So if the top was negative, I'm going to actually drop down 2 spaces. But the run was positive 3, so I'm going to go to the right, 1, 2, 3. And I'm going to go in reverse. I'm going to go up 2 and go to the left, 1, 2, 3. Up 2 and over to the left, 1, 2. Oh, that dot's going to be off the graph there. But that way I get a little more points to help me with my connecting of dots. And again, I want to look closely at my slope. It should be negative, and that's kind of what I have here with a y-intercept at negative 2. The last thing we'll take a look at is proving if lines are parallel. Lines are parallel when we have the same slope. I'm going to go ahead and jump right over here. It says lines with the same slope are parallel. That means they never cross or intersect. Which lines from our picture are parallel? Well, we don't know until we identify the slope. So because I have a picture, I'm not going to bother using these ordered pairs they gave me. I certainly could calculate that by y2 minus y1. If I don't want to do that, I'm going to go ahead and just use what they gave me, the picture. Let's see, if I go from the left dot to the right dot, I'm going to rise up 1. That's the rise. And I'm going to run over 1, 2, 3 points. So my blue slope is 1/3. What's the red slope? Let's see. They gave me this dot and that dot. We'll rise up 2, and I run to the right 1, 2, 3, 4, 5. So that's the red slope. What about my green slope? I'll use these 2 dots they gave me. I'm going to have to rise up 2 and head over 1, 2, 3, 4, 5, 6. Up 2 and to the right 6. But I can simplify that to be 1/3. Which lines in the figure are parallel? So we've got our same slope here. So the blue and the green lines are parallel. And I'm going to use the parallel symbol there. Blue and green are parallel. And why are they parallel? Because they have the same exact slope and their y-intercepts are different. If they had the same slope and the same y-intercept, they would be the same line. So let's take a look. Are the 2 lines parallel? Why or why not? So first you want to make sure all the lines are in slope-intercept form. So I'm going to go ahead and fix this one. Are those parallel? So I have a slope of 5 and I have a slope of negative 5. Nope, not parallel because they don't have the same slope. Let's take a look at this next one. This is actually in slope-intercept form. I don't know if you recognize that. It's just written backwards. So if I rewrite it in slope-intercept form, it's this. So here's my 2 equations. What's the slope of both of them? 3. And they have different y-intercepts. So these ones are parallel. 2 things have to happen for lines to be parallel. Same slope, but a different y-intercept. We'll take a look at the last one. I have to go ahead and solve this one first. So here I have a slope of negative 1/2, a slope of negative 1/2, and my y-intercepts are different. Notice this one doesn't say a y-intercept, so I'd have to put a +0 there. Two lines are parallel if they have the same slope but a different